Hello friends, I Deepak Prajapati welcome you in lecture number 13 on complex functions. In last lectures we have discussed about harmonic function and harmonic conjugates, and we have seen how to find out harmonic conjugate of a given harmonic function. Today we are going to discuss a very important method of constructing analytic function. Method is known as Milne Thomson method. Milne and Thomson is the name of mathematicians. These are two mathematicians, Milne and Thomson. So they have given the method of constructing an analytic function whose real part or imaginary part is known. So suppose you have given that u is real part of some analytic function f of z. Then how to construct this analytic function f of z whose real part is known. Similarly, if imaginary part of analytic function is given, then how to write down this analytic function. So that method is given by Milne and Thomson. So let us understand what is Milne and Thomson idea, and then we will do some examples based on this method. So suppose we want to determine an analytic function f of z equal to u+iv whose real part is known and imaginary part is not known to us. We know only real part of f of z, but it is given that f of z is analytic function. So if we use the idea of previous lecture, then we can find out harmonic conjugate of u, and then we can decide the analytic function f of z equal to u+iv. But this is shortcut method. Without finding out harmonic conjugate of u, we will be able to write down the analytic function. So this is shortcut given by Milne and Thomson. So we understand the idea of the method. It is given that f of z is analytic, therefore f of z is differentiable. So we can write the formula for derivative of f of z. It is f dash z equal to del u by del x plus I into del v by del x. Now v is unknown quantity, so we replace vx by uy. Because function is analytic, so u and v will satisfy Cauchy Riemann equations. So we are using this Cauchy Riemann equation, del u by del y equal to minus del v by del x. So therefore del v by del x is replaced by minus del u by del y. So derivative of function is now in terms of partial derivatives of u, and u is given. So we can find out partial derivatives of u, and we will have the formula for f dash z in terms of x and y. This right hand side is going to be function of x and y. So what is idea of Milne and Thomson? That you convert this right hand side in terms of z. That means you write your right hand side, or you convert your right hand side in terms of function of z. If this is possible, then left hand side is function of z. So if we integrate this function of z, we will be able to find out f of z. So the idea of Milne and Thomson is you have to put x equal to z and y equal to 0 in this right hand side. Put x equal to z and y equal to 0 in the right hand side of this equation. So we will get that del u by del x as a function of z and del u by del y as a function of z. So right hand side will be some function of z, say g of z, and then once this f dash z is written in terms of function of z, we have to integrate this f dash z with respect to z to find out its value. So the integration of f dash z is f of z, and whatever we obtain on this right hand side, we have to integrate that function with respect to z. Now because it is going to be function of z, so we can find out its integration with respect to z. But keep in mind, we have not discussed complex integration before this, so you can see my lecture series on complex integration to find out this integral which is required to write f of z, which is analytic function. Similarly, if imaginary part of f of z is known, then we can find out, then also we can write down the analytic function f of z. So if v is known, we will convert this partial derivative with respect to x in terms of partial derivative with respect to y. So f dash z is ux plus ivx, and using Cauchy Riemann equation we can replace del u by del x by del v by del y. So this is replaced by partial derivative with respect to y. Now we have this function v, imaginary part is known to us, so we can find out del v by del y and del v by del x. But this right hand side is a function of x and y, and we want to convert this in terms of z. So again we will put x equal to z and y equal to 0 in right hand side of this equation, and then after integrating we will obtain f of z. Okay, so this is very simple method to write down the analytic function whose real or imaginary part is known to us. We consider one example to understand this method. Find an analytic function f of z equal to u plus iv if u equal to x cube minus 3xy square. That is, real part of f of z is given, and also it is given that f of z is analytic function. So first we find out partial derivatives of u with respect to x and y. So u is x cube minus 3xy square. So the partial derivative with respect to x is 3x square minus 3y square is constant, derivative of x is 1. Partial derivative with respect to y is derivative of x cube is 0, because we are differentiating with respect to y. So x is constant, therefore x cube is constant, and because x is constant, this minus 3x as it is, and derivative of y square is 2y. So we have minus 6x into y. Now it is given that f of z is analytic, therefore function is differentiable, therefore f dash z is del u by del x plus I into del v by del x. Now u is given, so we replace this del v by del x by minus uy. Cauchy Riemann equation. We are using this Cauchy Riemann equation. Del u by del y is minus del v by del x. So we replace del v by del x by minus del u by del y, and then we put values of del u by del x and del u by del y. So del u by del x is 3x square minus 3y square, and del u by del y is minus 6xy, but here we have minus del u by del y, so it is going to be 6x into y. Now right hand side is function of x and y, so to convert it in terms of z, we will replace small x by z and y by 0 in this right hand side. So if we put x equal to z, we have 3z square and minus 0 because y is 0. Here also y is in the multiplication, so if we put y equal to 0, this is going to be 0. So finally f dash z is 3 into z square, and if we integrate, we obtain f of z equal to z cube plus c. Here we are using the fact that this z square function is analytic everywhere, so we can find out its integral using antiderivative concept. Okay, so you can see the lecture series on complex integration on my channel. Okay, I have uploaded enough lectures of complex integration. Okay, so from those lectures we are using the fact that if function is analytic everywhere, it has an antiderivative. So f of z equal to z cube plus c. So f of z equal to z cube is nothing but antiderivative of z square. So you can see we obtain f of z equal to z cube plus c. So this is the analytic function whose real part is x cube minus 3xy square. We take one more example. Find an analytic function f of z equal to u plus iv if imaginary part v is 3x square y minus y cube. So here first we find out partial derivatives of v. Del v by del x is 3y is constant, derivative of x square is 2x. So it is going to be 6xy. Derivative of y cube with respect to x is 0. Del v by del y is 3x square constant, derivative of y is 1 minus 3y square. Again, because f of z is analytic, it is differentiable. Therefore, we can write f dash z equal to del u by del x plus I into del v by del x. Now v is known to us, u is not given. So we replace del u by del x by del v by del y. Because function is analytic, so Cauchy Riemann equations will be satisfied. So we are using this Cauchy Riemann equation and we replace del u by del x by del v by del y. Then we substitute values of del v by del y and del v by del x. Del v by del y is 3x square minus 3y square and del v by del x is 6xy. So now this right hand side is function of x and y. So we put x equal to z and y equal to 0. So y equal to 0 will make this part 0 and this is 3z square minus 0. So again we obtain f dash z equal to 3z square. Z square is analytic everywhere. So if we integrate we will obtain z cube plus c. So you can see here also our function, constructed function is z cube plus c, but here imaginary part is given which is 3x square y minus y cube. In this example also we obtain f of z equal to z cube plus c, but here real part is given x cube minus 3xy square. Okay, so if you find out u plus iv, you will obtain z cube. So in this way we can construct the analytic function whose real or imaginary part is given using Milne Thomson method. Okay, so this is all about today's session. We have discussed how to construct an analytic function whose real or imaginary parts are given. So I hope you like this lecture. Thank you very much.